So hello dear students, in the today's lecture we will study about a relation between scattering angles in lab system and center of mass frame of reference. In the previous two lectures we have studied in detail about the collision in lab system and center of mass system, and if you watch those two lectures carefully, then we supposed that center of mass is moving with velocity v along the x-axis, and after the collision in lab system, mass m1 moves with velocity v1 at an angle alpha, whereas in center of mass frame of reference, the particle m1 moves with velocity v1 dash at an angle theta. So now we are to draw a correlation between scattering angle alpha and theta. Alpha is the angle of scattering of the first particle in lab system. Theta is angle of scattering of the first particle in center of mass system. So now for motion along x-axis only, so we will consider the components of the velocities along the x-axis. For v1 it will be v1 cos alpha, it will be v1 dash cos theta plus v. For motion along y-axis only, we will take y components. So it will be v1 sin alpha, it will be equal to v1 dash sin theta, and no component of v, this velocity, because it is in along x-axis and its component at 90 degree to it, it will be 0. Now divide equation number 2 by equation number 1. We will get v1 sin alpha, v1 cos alpha, v1 dash sin theta, v1 dash cos theta plus v. So it will be tan alpha, sin alpha over cos alpha is tan alpha, and here we divide each term by v1 dash. So tan alpha, it will be sin theta divided by cos theta plus v divided by v1 dash. So we mark this as equation number 3. So in the previous lecture we have derived the correlation between the velocities. So v1 dash, it was u1 dash, which is equal to m2 u1 divided by m1 plus m2. So this formula we have derived. So here initial velocity is u1, and v1 dash is final velocity in center of mass frame of reference. And one more formula we have derived, which is equal to m1 u1 over m1 plus m2. So from these two formulas we can easily get the value of v upon v1 dash. All the parameters will cancel out, u1, m1 plus m2, so it will be m1 upon m2. So we mark this as equation number 4. So from 3 and 4 we get our desired relation, sin theta over cos theta plus m1 by m2. So this is the relation between alpha and theta. Alpha is scattering angle in lab system, theta is scattering angle in center of mass system. So we have two special cases for this. If target particle is too heavy, if the target particle is very heavy, so m2 it will be much greater than m1. So m1 by m2 it will be very negligible. We can ignore this term. So tan alpha it will be sin theta by cos theta, which gives us alpha is equal to theta. Both angles in lab system and center of mass systems will be equal if target particle is much heavier. If the target particle and incident particle, both colliding particles, are of equal mass, so m1 will be equal to m2. So m1 by m2 it will be equal to 1. So tan alpha it will be equal to sin theta over cos theta plus 1. So we can simplify it like this, and it is 1 plus cos theta is cos square theta by 2. So 1, this cancel out, 2 cancel out. So tan alpha it will be equal to tan theta by 2. So which implies alpha is equal to theta by 2. So these are the correlations between the scattering angles in lab system and center of mass frame of reference. Next article is a relation between recoil angle in lab system and scattering angle in center of mass system. So dear students, as we have studied in the previous lecture, scattering angle in center of mass system is also equal to recoil angle in center of mass system. So you can read this article as relation between recoil angles in lab system as well as in center of mass system. And if we try to draw the diagram, then suppose this is the velocity of the center of mass, it is along the x-axis, and v2 is the velocity of the particle 2, and it is recoil angle is beta in lab system, and v2 dash it is the velocity and its recoil angle or angle of scattering, as both are equal, it is equal to theta. So you can depict it like this as well. So join this. Now again we will take the components, taking scattering along x-axis only. So along the x-axis we have two components. This is V2 cos beta. This is V2 dash cos theta. So both are equal to V2 cos beta, V2 dash cos theta, it is equal to V. So V2 cos beta, it is equal to V minus V2 dash cos theta. We mark this as equation number 1. Now along y-axis only, when we take the y components, then it will be V2 sin beta, it is equal to V2 dash sin theta. So divide the both equations, divide equation number 2 by 1. So V2 sin beta, V2 cos beta, it is equal to V2 dash sin theta, V minus V2 dash cos theta. So this cancels out, it is tan beta, V2 dash sin theta, V minus V2 dash cos theta. So divide by V2 dash both sides. So it will be V upon V2 dash minus cos theta. We mark this as equation number 3. So tan beta is equal to this. So as in the previous article, here we will be substituting the value of V divided by V2 dash. So as in the previous articles, we have derived these two relations in center of mass frame of reference, and V, it is equal to in lab system, and when we divide V divided by V2 dash, it will be 1. So from 3 and 4 we will get our desired relation. So tan beta, it is equal to sin theta divided by 1 minus cos theta. So it is 2 sin theta by 2 cos theta by 2, it is 2 sin square theta by 2. 2 cancels out, this cancels out, so it will be cot theta by 2. So tan beta, it is equal to cos theta by 2 divided by sin theta by 2, it will be cot theta by 2. So we can write this as equivalent to tan 90 minus theta by 2. So here beta, it will be equal to 90 minus theta by 2. So 2 beta multiplied by 2, it is 180 degree minus theta, or we can say 180 degree minus theta, it is equal to 2 beta. So this is the desired relation. In words we can write it like, what is this? This is the scattering angle in center of mass system. It is equal to twice into angle of recoil in lab system. So this is our required relation. So this is all for today. Keep in touch for next lectures as well. Thanks a lot.